In a previous video, we saw that the standard multiplication algorithm has complexity n squared, and we asked whether this can be improved. So in 1962, Karatsuba proposed a faster method to multiply two n-digit numbers, with the key idea being a divide and conquer. So essentially, he's going to split these numbers that you want to multiply into smaller instances of multiplication, and he's going to do something better there than what standard multiplication does. And I think the easiest thing is to go over an example. So let's say that you want to multiply 1,234 with 5,678. So the way this works with the Karatsuba algorithm is that you choose your base here, so here 10, and then what you do is you're going to split the number into two parts. So for example, so x here, we're going to write it as 12 times 10 squared plus 34. And y is going to be 56 times 10 squared plus 78, right? And then the idea is that x1 is then going to be this 12 here. x0 is going to be this 34. And y1 is going to be this 56 here. And y0 is going to be this 78. And what Karatsuba says is that you compute three multiplications. So you compute z2, which is going to be equal to x1 times y1. And so this is going to be 12 times 56, which will be 672. You also compute z0, which is going to be x0, y0. And so this will be 34 times 78, which will be 2,652. And also and this is where the magic happens, you compute this z1, which is x1 plus x0 times y1 plus y0 minus z2 minus z0. And so this is where the magic will happen, and we're going to analyze why. But for now, let's just calculate this. So this will be 12 plus 34 times 56 plus 78 minus 672 minus 2,652. And this will be equal to 2,840. And what Karatsuba says is that your answer, x times y, is just going to be z2 times 10 to the 4 plus z1 times 10 squared plus z0. And so this is going to be, if you just replace z1, z2, and z3 and do the operations, this will give you 7,006,652. Okay, now the magic here is going to be in this part here, and we're going to have a slide just for that, but I'll show it here also. The idea is that if you are multiplying x and y, and you write it in this form here, so you have two things that you're adding and two things that you're adding, and you're multiplying it. If you were to just distribute, you would have to do 4 multiplications. And what Karatsuba is doing is he's essentially doing only 3 multiplications. And the idea is that this part is sort of doing the work of 2 multiplications, but with just 1. And that's where all the gains are going to come from. So let's see how this works. So again, recall our example. So we're multiplying these two numbers. And so then when we expand them, this is what they look like, right? And now, if you were to just multiply them using the standard algorithm here, you would do 12 times 56 here, then times 10 to the 4 because of the 10 squared, of course. Then you would do 12 times 78 with a 10 squared appearing. But there's another 10 squared appearing, which is this 34 times 56. And then finally this 34 times 78. And notice that you have 4 multiplications appearing here. What Karatsuba is saying is compute these 3 terms using only 3 multiplications. Now this term, of course, is going to appear here. So we need this part. This z0 is going to appear here. And the idea is that instead of getting this term by doing 2 multiplications, what Karatsuba does is he does only 1 multiplication, and then he subtracts 2 things that he computed before, and he's able to get this. So let's write this out here carefully. So z1, if you open up, let's just open up this part here. If you open up this part, you get 12 times 56 plus 12 times 78 plus 34 times 56 plus 34 times 78. And the idea here is that to get this multiplication here, these terms actually appear here. And the extra terms, notice that they were computed before. So this is just z2 here. And this is just z0. So the idea is that when you compute this multiplication, you get what you want, but you need to remove these 2 things. But you already computed them before, right? And the whole point is that if you look at what Karatsuba does, is he's essentially doing less multiplication. So instead of 4, he's doing 3 of them. And he has to do some extra additions. But at the end of the day, it's going to be worth it.